Unit 1, Part 3. Introduction to TIVA TM4C123G. So, the TIVA C series TM4C1123G Launchpad Evaluation Board is a low-cost evaluation platform for ARM Cortex M4F based microcontroller. The TIVA C series Launchpad design highlights the TM4123GH6 PMI microcontroller USB 2.0 device interface, hibernation module, and motion control plus pulse width modulator module. The TIVA C series Launchpad also features a programmable user buttons and an RGB LED for custom applications. The stackable headers of the TIVA C series Launchpad Booster Pack Excel interface demonstrate how easy it is to expand the functionality of this TIVA C series Launchpad when interfacing to other peripherals on many existing Booster Pack add-on boards as well as future products. So, this diagram shows the photo of TIVA C series launch pad. This is the diagram which consists of USB, power selection switch, USB connector, green power LED, TIVA microprocessor. So this is TIVA microprocessor, reset switch, RGB user LED, booster pack, TIVA TM4C 123GH6 PMI microcontroller, user switch. There are two user switch, also launchpad compatible booster pack interface, the TIVA C series booster pack Excel interface. So these are the components now. There is an overview of TIVA C series microcontroller as well as the details on TM4C123GH6PM microcontroller. Now, the TIVA C series ARM Cortex M4 microcontroller provide top performance and advanced integration. The product family is positioned for cost-conscious applications requiring significant control processing and connectivity capabilities such as low-power handheld smart devices, gaming equipment, home and commercial site monitoring and control, motion control, medical instrumentation, test and measurement equipment, factory automation, fire and security, smart energy, smart grid solutions, intelligent lighting control, and transportation. For applications requiring extreme conservation of power, this microcontroller features a battery backup hibernation module to efficiently power down the TM4C123GH6PM to a low power state during extended periods of inactivity. With power up or power down sequencer, a real time counter, as well as multiple wake from hibernate options and dedicated battery backed memory, and the hibernation module positions the TM4C123GH6PM microcontroller perfectly for battery applications. In addition to that, this microcontroller offers the advantage of ARM's widely available development tools, system on chip, that is SoC infrastructure, IP applications, and a large user community. Additionally, the microcontroller uses ARM's thumb compatible instruction set to reduce memory requirements and cost. Finally, Much of this microcontroller code is compatible to the TIVA C series product line and providing flexibility across design. Now there are some features that the TIVA C this microcontroller: motion control PWM, USB micro A and micro B connector for the USB device and host, and on the go, that is OTG connectivity, RGB user LED, two user switches, which is already seen in the previous diagram. Two user switches, available I/O, that is input output brought out to headers on the point 1 in grid, onboard ICDI, switch selectable power sources, reset switch, preloaded RGB quick start application supported by TIVA, where for C series software including the USB library and the peripheral driver library. The TIVA C series TM4C123G Launchpad Booster Pack XL interface, which features stackable headers to expand the capabilities of the TIVA C series Launchpad development platform. Next, this microcontroller overview. Now, there are some features and its description. So core is ARM Cortex M4F processor core. Performance is, it has 80 MHz operation and 100 DMIPS performance. Flash 256 KB single cycle flash memory. System SRAM, it has a 32 KB single cycle SRAM. EEPROM, 2 KB of EEPROM. Internal ROM loaded with TIVA for C series software. Next, communication interface: universal asynchronous receiver or transmitter, that is UART. It has a 8 UART. Synchronous serial interface, that is SSI, 4 SSI modules. Interconnected circuit, that is I2C, 4 I2C modules with 4 transmission speeds including high speed mode. Next, controller area network, that is CAN, 2 CAN 2.0 AB controllers. Universal serial bus, that is USB, it has 2.0 OTG or host or devices. Next is system integration: micro direct memory access, ARM at prime cell at 32 channel configuration micro direct memory access controller. General purpose timer, 16 or 32 bit GPTM blocks and 64 bit wide GPTM blocks. Watchdog timer, 2 watchdog timers are there. Hibernation module, low power battery backed hibernation module. General purpose input output has 6 physical general purpose, that is GPIO blocks. Next, advanced motion control, pulse width modulator, 2 PWM module, each with 4 PWM generator block and a control block for a total 16 PWM output. Next, quadrature encoder interface, that is QEI, it has 2 QEI module. Next, analog support, analog to digital converter ADC, 12-bit ADC module with maximum sample rate of 1 million sample per second. Analog comparator controller, 2 independent integrated analog comparators. Digital comparators, 16 digital comparators. JTAG and serial wire debug, that is SWD, 1 JTAG module with integrated ARM SWD. Package 64 pin LQFP. Operating range for industrial, it is -40° to 85°C temperature range, and extended -40 to 105°C temperature range. This is ambient temperature range. Now this diagram shows the Features on the TM4C123GH6PM microcontroller. Here there are two on-chip buses that connect the core to the peripherals. The advanced peripheral bus, that is APB bus, is legacy bus. The advanced high performance bus, that is AHB bus, provides better back-to-back access performance than ABP bus. So this diagram is high level block diagram, or this is TM4C123GH6PM microcontroller high level block diagram. It consists of JTAG, system control and clocks, RAM, flash, bus matrix, SRAM, DMA, EEPROM, GPIO, USB OTG, analog comparator, PWM comparator. In bracket they have given a number, that is it consists of that much quantity. So here they have given analog comparator in bracket 2. So it consists of 2 analog comparator. Next, UART, I2C, CAN controller, 12BK ADC channels, QEI, general purpose timer, hibernation module, watchdog timer. So DMA, EEPROM, GPI, watchdog timer, hibernation module, general purpose timer. These 6 blocks are system peripherals. Next, USB OTG, SSI, UART, I2C, CAN controller. These are serial peripherals. And the last, analog comparator, PWM, QEI, and 12BK ADC channel. These analog comparator and 12BK ADC channel, this is analog peripherals. And the last one, PWM and QEI, these are motion control peripherals. So basically there are 4 peripherals: system peripheral, serial peripheral, analog peripheral, and motion control peripheral. Next, features of this microcontroller. So all the members of this TIVA C series, including TM4C123GH6PM microcontroller, are designed around an ARM Cortex-M processor core. The ARM Cortex-M processor provides the core for high performance, low cost platform that meets the needs of minimal memory implementation, reduced pin count, and low power consumption, while delivering outstanding computational performance and exceptional system response to interrupts. So the first one, processor core, in that it has a 32-bit ARM Cortex M4F architecture optimized for small footprint embedded applications. Next is 80 MHz operation, 100 dm IPS performance. Next feature, outstanding processing performance combined with the fast interrupt handling. Next is thumb 2 mixed 16 by 32 bit instruction set delivers high performance expected of 32-bit ARM core in a compact memory size, usually associated with 8 and 16-bit devices. Next, IEEE 754 compliant single precision floating point unit, 16-bit SIMD vector processing unit. Fast code execution permits lower processor clock or increases sleep mode time. Hardware architecture characterized by the separate buses for instruction and data, efficient processor core system and memories, hardware division, and fast digital signal processing oriented, multiply, accumulate, saturating arithmetic for single processing, deterministic high performance interrupt handling for time critical applications, memory protection unit, that is MPU, to to provide a privileged mode for protected operating system functionality, enhanced system debug with extensive breakpoint and trace capabilities. Serial wire debug and serial wire trace reduce the number of pins required for debugging and tracing. Migration from the ARM7 processor family for better performance and power efficiency. Optimized for single cycle flash memory usage up to a specific frequencies. And last one, ultra low power consumption with integrated sleep mode. So these are the features for the processor core. These all are theory part. We have to see all the blocks of this block diagram. So next is system timer. The ARM Cortex M4F includes an integrated system timer. It provides a simple 24-bit clear on write discriminating wrap on zero counter with flexible control mechanism, and the counter can be used in several different ways. For example, an RTOS, that is real time operating system, tick timer that fires at programmable rate, and invokes a system timer routine, a high speed alarm timer using a system clock, a variable rate alarm or a signal timer. The duration is the range dependent on the reference clock which is used and the dynamic range of the counter. A simple counter used to measure a time to completion and time used. An internal clock source control based on meeting durations. The next is NVIC, that is nested vectored interrupt controller. This controller includes the ARM nested vector interrupt controller, that is NVIC. The NVIC and the Cortex M4F priorities and handle all exceptions in handler mode. The processor state is automatically stored to the stack on an exception and automatically restored from the stack at the end of the interrupt service routine. Software can set 8 priority levels on 7 exceptions and 78 interrupts. The deterministic fast interrupt processing always 12 cycle or just 6 cycle with tail chaining. External non-maskable interrupt signal available for immediate execution of LMI handler for safety critical applications. Dynamically reprioritizable interrupts. Exceptional interrupt handling via hardware implementation of required register manipulations. Next is system control block. It provides system implementation information and system control, including configuration, control, and reporting of the system exceptions. Next is MPU, that is memory protection block. It supports the standard ARM7 protected memory system architecture model. The MPU provides full support for the protection region, overlapping protection regions, access permissions, and exporting memory attributes to the system. Floating point unit, that is FPU. Next point is FPU, that is floating point unit. It fully supports single precision add, subtract, multiply, divide, multiply, and accumulate and square root operation. It also provides conversation between fixed point and floating point data formats and floating point constant instructions. 32-bit instructions for single precision data processing operations, combined multiply and accumulate instruction for decreased precision, hardware support for the conversion, addition, subtraction, multiplication with optimal accumulate, division and square root, hardware support for the denormals and all IEEE rounding modes. 32 dedicated 32-bit single precision registers also addressable as 16 double word registers. Decoupled three-stage pipeline. Next is on-chip memory. The TM4C123GH6PM microcontroller is integrated with the following set of on-chip memory and features. First is 32 KB single cycle SRAM. Next 256 KB flash memory. 2 KB EEPROM. Internal ROM loaded with TivaWare for C series software. TivaWare peripheral driver library, TivaWare bootloader, advanced encryption standard cryptography, tables, cyclic redundancy check and error detection functionality. Next is SRAM. This microcontroller provides 32 KB of single cycle on-chip SRAM. The internal SRAM of the device is located at offset 0 by 2000 0 by 200.0000 of the device memory map. Because read modify write operations are very time consuming, ARM has introduced a bit banding technology in the Cortex M4F processor. With a bit band enabled processor, certain regions in the memory map can use address aliases to access individual bits in a single atomic operation. Data can be transferred to and from SRAM by the following masters, that is micro direct memory access controller and USB. Next is flash memory. This microcontroller provides 256 KB of single cycle on-chip flash memory. The flash memory is organized as a set of 1 KB blocks that can be individually erased. Erasing a block causes the entire contents of the block to be reset to all ones. These blocks are paired into a set of 2 KB blocks that can be individually protected. The block can be marked as a read-only or execute-only, providing different levels of code protection. Read-only block cannot be erased or programmed, protecting the contents of those blocks from being modified. Execute-only blocks cannot be erased or programmed, and it can only be read by a controller instruction fetch mechanism, protecting the contents of those blocks from being read by either the controller or by the debugger. So it consists of 256 KB of on-chip flash memory. Next is ROM. This microcontroller ROM is pre-programmed with following software and programs: TivaWare peripheral driver library, TivaWare bootloader, advanced encryption standard cryptography, tables, cyclic redundancy check, that is CRC, error detection functionality. The TivaWare Peripheral Driver Library is royalty-free software library for controlling on-chip peripherals with a bootloader capability. The library performs both peripheral initialization and control function with the choice of pole or interrupt-driven peripheral support. In addition, the library is designed to take full advantage of the stellar interrupt performance of the ARM Cortex M4F core. No special programs or the custom assembly code prolong functions are required. For applications that require in-hand programmability, the royalty-free TivaWare bootloader can act as an application loader and support in-field firmware updates. The Advanced Encryption Standard is publicly defined encryption standard used by the US government. The CRC, that is cyclic redundancy check, is a technique to validate a span of data that has the same contents as when previously checked. This technique can be used to validate correct receipt of message, to validate data after decompression, to validate the flash memory contents that have not been changed, and for other cases where the data needs to be validated. A CRC, that is cyclic redundancy check, is a preferred over a simple checksum because it catches changes more readily. Next is EEPROM. This microcontroller include an EEPROM with following feature. First is 2 kilobytes of memory accessible as 512 32-bit words, 32 blocks of 16 words each, built-in wear leveling, access protection per block, lock protection option for the whole peripheral as well as per block using 32-bit to 96-bit unlock codes. Interrupt support for write completion to avoid polling, and endurance of 500k writes to 15 million operations per each 2-page block. Next is serial communication peripherals. This controller supports both asynchronous and synchronous serial communication with 2 CAN A and B controller, USB to 8 UART with IRDA 9-bit and ISO 7816 support, 4 I2C modules with 4 transmission speed including high speed mode, 4 synchronous serial interface module, that is SSI. Now the next part is it provides the more detail on each of above these communication functions. In that, the first one is CAN, that is controller area network. This microcontroller include 2 CAN unit with following features. First one, CAN protocol version 2 part A/B, bit range up to 1 Mbps, 32 messages objects with individual identifier mask, maskable interrupt, disable automatic retransmission mode for time triggered CAN applications, programmable loop back mode for self test operation, Programmable FIFO mode enables storage of multiple message objects cluelessly attaches to an external CAN transceiver through the CAN transmitter and CAN receiver single set work. The CAN, that is Controller Area Network, is a multicast shared serial bus standard for connecting electronic control unit, that is ECU. It was specifically designed to be robust in electromagnetically noisy environment, and it can utilize a different balanced line like RS485 or twisted pair wire. A transmitter sends a message to all CAN nodes. Each node decides on the basis of identifier received whether it should process the message. The identifier also determines the priority that the message enjoys in the competition for bus access. Each message can transmit from 0 to 8 bytes of user information. Next is Universal Serial Bus. This USB module has following features. It complies with USB-IF, that is Implementers Forum Certificate Standard, USB 2 full speed, that is 12 Mbps, and low speed 1.5 Mbps operation with integrated PHY. Link power management support, which uses the link state awareness to reduce a power usage. 4 transfer type, that is control, interrupt, bulk and asynchronous. 16 endpoints isochronous. 16 endpoints, one dedicated control in endpoint and one dedicated control out endpoint in endpoint and out endpoint. 7 configurable in endpoint and 7 configurable out endpoint. 4 KB dedicated endpoint memory. One endpoint may be defined for double buffered 1023 byte isochronous packet size, VBUS group, and valid ID detection and interrupt. Efficient transfer using micro direct memory access controller. Universal Serial Bus, that is USB, is a serial bus standard designed to allow peripherals to be connected and disconnected using standardized interface without rebooting the system. This microcontroller supports 3 configurations in USB to full and low speed, USB device, USB host, and USB on the go. Next is UART. UART, that is Universal Asynchronous Receiver or Transmitter. It has the following features: the programmable baud rate generator, allowing speeds up to 5 Mbps for regular speed and 10 Mbps for high speed. Separate 16-byte transmit and receive FIFOs to reduce CPU interrupt service loading. Programmable FIFO length, including 1 byte deep operation, providing conventional double buffered interface. FIFO trigger level of 1 by 8, 1 by 4, 1 by 2, 3 by 4, and 7 by 8. Standard asynchronous communication bits for start or stop and parity. line break generation and detection, fully programmable serial interface characteristic, 5, 6, 7 or 8 data bits, even odd sticks or no priority bit generator detection, 1 or 2 stop bit generation, IRDA serial IR encoder decoder providing. So UART, that is universal asynchronous receiver or transmitter, is integrated circuit which is used for RS-232C serial communication containing a transmitter and a receiver. The TM4C123GH6PM microcontroller include 8 fully programmable UART. Although the functionality is similar to 16C550 UART, this UART is not register compatible. The UART can generate individually masked interrupts from the RX, that is receiver or transmitter modern flow control and error conditions. Next feature, its support for communication with ISO 7816 smart cards, modern flow control, EIA 485 9-bit support, standard FIFO level and end of transmission interrupt, efficient transfer using micro direct memory access controller, separate channel for transmit and receive signal request accepted when data is in FIFO, that is first in first out burst request accepted at programmed FIFO level, transmit signal request assorted when there is a space in the FIFO burst request accepted at program FIFO level. Next is I2C, that is inter-integrated circuit. This microcontroller includes 4 I2C modules with following features. The first is devices on the I2C bus can be designed as either a master or a slave. In that it supports both transmitting and receiving data as either a master or slave, and also it supports simultaneous master and slave operation. There are 4 I2C modes: master transmit, master receive, slave transmit and slave receive. It has 4 transmission speeds. Standard it has 100 kbps, for fast mode 400 kbps, fast mode plus it has 1 mbps, and high speed mode it has 3.33 mbps. Next feature is clock low timeout interrupt, dual slave address capability, glitch suppression, master and slave interrupt generation. Master generate interrupt when a transmit or receive operation complete or abort due to the error. Slave generate interrupt when data has been transferred or requested by a master, or when start or stop condition is detected. And the last feature is master with arbitration and clock synchronization, multi-master support, and a 7-bit addressing mode. The I2C, that is inter-integrated circuit bus, provide bidirectional data transfer through a two-wire design, that is a serial data line SDA and serial clock line SCL. The I2C bus interface to external I2C devices such as serial memory, RAM and ROM, networking devices, LCDs, tow generators, and so on. The I2C bus may also be used for system testing and diagnostic purposes in product development and manufacture. Each device on I2C bus can be designed as either a master or slave. Both I2C master and slave can generate the interrupt. Next is SSI, that is synchronous serial interface. It has the following features: that programmable interface operation for free scale SPI, microwire or Texas Instrument synchronous serial interface, master or slave operation, programmable clock bit rate and prescaler, separate transmit and receive FIFOs, each 16-bit wide and 8 locations deep, programmable data frame size from 4 to 16 bits, internal loop back test mode for diagnostic debug testing, standard FIFO based interrupts and end of transmission interrupt, efficient transfer using micro direct memory access controller in that it has a separate channel for transmit and receive single request accepted when data is in FIFO, that is first in first out. Burst request accepted when FIFO contains 4 entries, and it transmit a single request accepted when there is a space in FIFO. Burst request accepted when 4 or more entries are available to be written in the FIFO. So synchronous serial interface is a 4-wire bidirectional. It is a 4-wire bidirectional communication interface that converts data between parallel and serial. The SSI module performs a serial to parallel conversion on data received from a peripheral device and parallel to serial conversion on the data transmitted to a peripheral device. The SSI module can be configured as either master or slave device. As a slave device, the SSI module can also be configured to disable its output, which allows a master device to be coupled with multiple slave devices. The transmission and the reception paths are buffered with separate internal FIFO. The SSI module also includes a programmable bit rate clock divider and prescale to generate the output serial clock derived from the SSI module's input clock. Bit rate are generated based on the input clock, and the maximum bit rate is determined by the connected peripheral. So this is all about SSI, that is synchronous serial interface. Thank you.